I'm Cameron Fahrig. I was the reporter for Group 2 for the commercial air conditioning experiment. A little reiteration of the objectives of the experiment. We wanted the students to understand the efficiency of an air handling unit, its physical components, and the variables in the air conditioning equation that we use to find what we need about air conditioning. So a little overview of the experiment. We observed and recorded data for the air handling unit. We were looking at two variable air volume boxes, which were chamber A and chamber B. We recorded data every 30 seconds for 30 minutes, which gave us 60 data points for each VAV box. So the metrics that we used the time in minutes, we did the chamber temperatures in Fahrenheit, and then the chamber's volumetric flow rates in cubic feet per minute. So if you look at this chart, our set point was about 74, and the supply air temperature was about 55, so each VAV box pretty much just oscillated around each other. They just took over and made sure that the set point stayed pretty neutral. So the expected results, these were some sample calculations that I did. You can see that chamber A only has 3 thermal resistances, so that's a pretty low thermal resistance. A sample change in temperature and area of the room, we get about 645.16 BTU per hour, which is a unit of power. So the experimental results that I got from the chamber A average temperature minus the chamber A discharge temperature, we got about 739.79 BTUs per hour. So it was a little higher than what was expected, but without an actual reading of the area of the room, that's kind of expected. And then the expected results for chamber B, if you notice that we have 5 thermal resistances included, so the chamber B, it encounters a lot more thermal resistance, so it probably is going to have a lower heat rate. And with that, you see that we have the heat rate is about 310.88 BTUs per hour, so that's pretty intuitive for us. With the experimental results, we note that chamber B had a lower volumetric flow rate than chamber A, and calculating with the average temperature minus the discharge temperature, we see that the heat rate was 222.09 BTUs per hour. So that's pretty, that jives with what we got from the expected results, the pre-experimental results. The theoretical results were based on sample values, so they weren't exactly going to jive with the exact values that we were getting. So the experimental results, they provided the same relationship. Basically, the chamber A is going to have a higher heat rate than chamber B, and that's mainly attributed to the increased thermal resistance in chamber B. That contributes to a larger heat rate than chamber A. I anticipate that these results will be on par with the other sections. I know some sections had a problem with recording an accurate set point, so they weren't exactly going to match up with ours, so I thought it'd be less confusing to leave that out. The results are just going to be slightly different based on those extraneous variables. So next we have the psychrometric chart used to plot the coil line, which represents the amount of cooling and dehumidification being done to the air that passes through the AC unit. So the values we needed were the entering air dry bulb temperature, which is marked by ENT, the entering air relative humidity, which is also ENT, the leaving air dry bulb temperature, and the leaving air relative humidity. So if you see on the chart right here, we match up our values for the relative humidity and the entering temperature, and then we plot the leaving temperature and humidity, and we make a coil line, and that intersects the saturation temperature line right here, and that gives us our ADP. The apparatus dew point, which is the temperature of cooling coil, the pre-experimental reading was about 48.5, and our coil line reading was 51. So they're pretty similar to each other, but I would go more with the chart than the psychrometric reading that we got from the meter. You can also measure the efficiency of the AC unit. We get in the lab manual, we're given the AC unit size rating, which is the maximum amount of heat that can be absorbed That was about 5,000 BTUs per hour, and then we can also look at the electrical input to the AC unit, which is the amount of power being used by the AC unit. That was about 580 watts for this experiment. That could give us our energy efficiency rating, which was, pretend that these boxes are around these values for me, and we get 8.621 BTUs per hour per watt. They're both units of power, but you use the coefficient of performance to convert the watts to BTUs per hour, and that gives us a coefficient of performance of about 2.527. And for my conclusion, I'd say that some uncertainties to be aware of were the inconsistent sample timing. Like that was previously mentioned, we recorded data manually each 30 seconds, so each time you input it manually into Excel, it's not going to be the exact same timing on each minute, and pretty much you're constantly inputting stuff, so it's not measured each 30 seconds. Chambers are measured about like 15 seconds apart, depending on how fast you can enter in the values. And also we had a differing set point. We were noted at the beginning of the experiment that the chamber had been set to about like 60 or so, but it should be at 55, so that can be also taken into consideration to make the experiment a little better next time. Thank you.